Well, good afternoon. My name is Patrick Cook. Welcome to this live stream. What we're going to do in this live stream and subsequent others is we're going to be talking about Mandelbulb rendering. All right. So the importance of rendering and understanding rendering within the Mandelbulb application and how to control is very important. All right. So what we're going to do is let's start by setting up a fractal situation here, so that we've got something that we can actually talk about. All right. So what I'm going to do, I've just started the Mandelbulb application. All right. So here's the main editor, and we've got the formulas panel up, and over here is the navigator. So what I'm going to do is I'm going to set up a fairly simple fractal scene, something that we can refer to and be able to demonstrate some of the controls that are going to be very important for rendering. Now, those controls are down here in the calculation panel. So we're in this live stream, we're going to begin to talk about these controls. These are render-related controls, and in subsequent live streams as well. Let's get this Mandelbulb set up for us. All right. Well, I'm just going to take something pretty simple. I'm going to take an amazing box in formula slot number 1. I'm in alternate mode. All right. In formula slot number 2. I'm going to do an A box VS. Let's see. A box vary scale. Okay, that's pretty cool. Formula slot number 3. I'm going to set up another Mandelbulb box. It's very interesting when the Mandelbox formulas are combined in alternate hybrid mode. These are the hybrid modes. It makes some very interesting designs. Okay, so let's render this out. Let's see what we have. Now, we're buried inside of the fractal right now. And that's key. That's key to understand why we're buried inside this fractal. Well, let's get unburied so that we've got something we can actually look at. Now, I'm going to pull the parameter over to the navigator. All right, and now what I'm going to do is I'm going to take formula number 1, which is an amazing box. I'm just going to scale that back so that I get out of the fractal. Good enough. Now I'm going to go to formula number 3, which is another amazing box, and I'm going to scale that. Okay, good. This is giving us something to look at, something to work with as we go over the rendering controls, which is the point of this live stream. All right, so I'm going to go back over to formula number 2. This is the A box vary scale, and I'm just going to kind of play with that a bit. Okay, yeah, that's good. That's good. All right, so now I'm going to walk in on this surface here. All right, this is good. Beautiful. All right, so all I'm doing here is I'm just giving us something, an image that we can talk around, okay? So now I'm going to push that back to main so that we have it here. All right, so please follow along. In alternate hybrid mode, set up a formula. For Formula 1, A box, amazing box. That's under the 3DA. Okay. Formula slot number 2, set up an A box vary scale. That's also under 3DA, right there. Okay, and formula slot number 3, set up an amazing box. Come over here. Don't try to replicate what I have over here. Just get yourself something that it will give you some level of detail and a nice structure. Don't try to replicate what I have here in the navigator. All right, now, what we want to do is we want to understand this stuff over here. All right, but to kind of really understand what's going on in this calculation panel here, you see DE stop, you see vary DE on FOV, Raystep Multiplier. Those are all very critical controls. But what's happening here behind the scene is it's a rendering process that is referred to as ray marching. All right. Now, ray marching is a process of from the camera's position, it shoots out a ray. All right. Now, the ray is a mathematical construct. And along this ray, it's actually performing calculations. It does a step. Did I hit anything? Yes or no? Another step. Did I hit anything? Did I hit an object? Okay. Another step. So ray marching is a process of shooting out a ray from the camera position and stepping along the ray to determine whether or not the ray is hitting an object. Now let me explain. Now if take a look at our graphic here. What's very interesting is that these are actually objects. They are fractal. They're fractal objects that are calculated based upon your formula setup. They're calculated, and they are objects. They're objects in a world scene. Okay, they actually exist. All right. Now, obviously, they're mathematical constructs, but they actually are objects within the scene. Now, ray marching is a process of shooting out a ray to determine whether or not we hit anything, we hit an object in the scene. Okay? Ray tracing is a process that's utilized in polygon type of structures where an object, or I should say an image on a screen, is actually made up of polygons. In the case of the Mandelbulb, Mandelbulb3D, these are not polygons. These are actual pixels, all right, that are represented, that are rendered from actual objects within the scene. The job of the ray marching rendering process is actually to convert the world space where objects exist into screen space, which is a simulation of 3D, but on a 2D surface. 2D surface meaning a display monitor. Okay. So the job of ray marching is to shoot out a feeler, if you will, and say, is there an object out there? And if there is, where is it? Okay. Now, let's get set up here again. Again, the actual graphic that's on your screen doesn't matter. Okay. Now, okay. So the key to good renders within the Mandelbulb application is to understand the rendering process, the ray marching rendering process. We have controls here that we, as the user, the artist, can manipulate in order to better control the rendering process that occurs within the Mandelbulb application. But we need to understand how that graphic is being formed on that screen in order for us to be able to get the maximum quality, or at least a good quality balanced with render time. All right. Now, all right, let's kind of set some stakes in the ground. First of all, you get no graphics unless it's rendered. You get a black screen if the rendering process doesn't occur. Now, what this rendering process is, it's for every pixel on the screen, the renderer has to shoot out a ray, step through the process to determine whether or not a hit has occurred, a hit with an object or not, and then convert all of that data into a pixel. If we had a resolution of 1920 by 1080, we have what? 2,202,073,000 and some change pixels that all need to be rendered and converted to screen space or a display. So nothing happens. We get no images whatsoever unless we render each and every pixel within the Mandelbulb screen. Now, with that said, there has to be, my example of 1920 by 1080 with 2 million pixels, there has to be 2 million rays that are shot out in order to get that image drawn on that screen. 2 million rays, 2 million shoots. All right, now, understanding the process of shooting out these rays is key, because if you don't get the settings right, you're going to have a poor quality graphic. All right. One of the key controls within the rendering process within Mandelbulb is called the DE stop. Now, the DE stands for distance estimate stop. All right. That brings up the important point that the ray marching process that the Mandelbulb application utilizes is based upon the distance estimate ray marching methodology. And all that means is that these steps that I referred to, these steps are estimated. How far should I go, is what the renderers say. Should I shoot here? Okay, that looks good. Should I shoot here? That looks good. Okay. So the DE stands for distance estimate and stop. Now let me just give you an example of how this DE functions. Let's so we have our screen here. I think what I'm going to do is I'm going to set that up a little bit higher. I want to make that 16 by 9. Okay, there we go. A little bit better so that we can see it. Now, this is a DE stop of 1.6. I'm going to set that to a DE stop of 10. All right, 10. Now, I'm going to render that out. Now, you see what's going on. Turn on my magnifier here. You can see that we've lost detail. Remember the detail we had over here at the navigator, okay? We've lost detail, and everything is soft. You notice that the edges are soft, all right? And you also notice that there's some sketchiness down here, all right, some roughness. A DE stop of 10 in this case gave me that result. All right. Now let's do a DE stop of 0.1. 0.1, calculate. Okay. Now, let's turn on our magnifier and take a look now. Now we have a lot of detail, but it's so much detail that the quality of the image is actually very damaged, because now we are picking up artifacts. All right, we're oversampling. I'll explain what that means in a little while, but we're oversampling right now. Okay? All right, so compare that with my DE stop of 10. All right, calculate. And you can see that this DE stop is actually critical to the quality of the image that we get. Now, as we go along, I'm going to be explaining what this DE is, this DE stop. I'm going to explain why this is happening. Now, let's just set that to the DE stop to 2. All right, turn on our little magnifier here. All right, well, the detail's starting to come back, but it's still soft. All right, let's set this to 1. Okay, all right, now we're getting more detail, but the detail really isn't all that great. All right, now, what I would have to say what most Mandelbulb artists do is that they will fuss with this. They'll put it up, they'll put it down, they'll change it, they'll re-render, and they'll see what happens. That's probably what most people do. And they do it that way because they don't understand what that DE stop is. We're going to change that in this live stream and subsequent ones. You're going to understand what that DE stop is thoroughly. Okay, so now, so we see here that this DE stop, set very high, 10, gave us a lot of softness, very soft. The DE stop of 0.1 was so detailed that it was actually ugly. And then we did 2, and then we did 1, so we're kind of fussing back and forth. We're trying to figure this out. We're trying to get a good graphic, but we're guessing. We don't want to guess anymore. All right, now, let's take a moment here and see if we can visualize, based upon what you saw here, of how the DE stop actually impacted the quality. I think now when I describe this ray marching process, I think you'll be able to better appreciate the ray marching that goes on. So let's do this. Let's do this. Let's go over to my little whiteboard here. Okay. And what I want to do is I want to kind of point out this whole process of this ray marching. Okay, so what I'm going to do is I'm going to make a camera here. Now, let's put an object in the screen here. This is a fractal object. This is a Mandelbulb. And as I explained before, I'm going to shoot out a ray. Now, the ray is a mathematical construct. All right, it's not a laser beam or anything like that. It's a mathematical calculation that occurs that from the camera's position, it will shoot out a ray, a path, if you will. Now, what the Mandelbulb, I want to do something here. Okay, I want to get, see if I can get my camera back in the scene here. That's a little bit better. All this techie stuff, right? All this OBS and all this camera stuff going on. All it's crazy. All that's more complicated than the Mandelbulb. Anyway, so I have here now, I have a camera, I have a ray. Now, this whole distance estimation, all right, the DE, distance estimate. Here's the process. What the math, the internal math of the Mandelbulb does is it says, look, where is an object out in the world, out in the scene? Where is a Mandelbulb? Where is it? I don't know. I don't know. I don't know where it is. So what it does, what the calculation, what the math, the internal math does, is it says, well, okay, I'm going to step this far out, whatever this far means. Don't worry about it. And it says I'm going to make a step of n distance. And it says, okay, so it does this sample. All right, you can think of this as a sample. And it says, did I hit anything? Well, no. There's no surface. I didn't hit a surface. Now remember now, these fractal objects, they're actual objects in the scene. They're not polygons. They actually are bulbs that's sitting there doing stuff. All right, so the renderer says, well, I didn't hit anything, so let me try it again. All right, did I hit anything? At that sample? No. No hit, no hit. All right. Now, the process continues. Still no hit, so I'm gonna do that. All right, did I hit anything at that sample? No, I didn't. All right. So the process of ray marching very basically says along the ray, do a sample. Did you hit anything? Yes or no? No. Do another sample. Did you hit anything? Yes or no? No. Do another sample. Okay. Now it gets interesting. So then what it says, well, okay, then I've done a step like this, that amount, that amount, that amount. And then it says, well, I'm pretty far out there. I've really reached out pretty far, and I haven't found a fractal object surface yet. Now, so it says, well, okay, then I can probably do another step that might be similar to that size. So, yeah, let's go ahead and do it. So there's another step. All right, and here's another sample. Did I hit anything? No. So then it says, well, okay, there is some data that is coming back. It's coming into the calculation. I'm trying to draw an arrow there. Some data. The fractal the fractal formula itself is providing some information to this mathematical process of stepping. And now the ray marching system says, okay, I think I'm getting close. All right. I think I'm getting close to a fractal. So what I'm going to do is I'm going to take a smaller step. So now it's a new sample. I still didn't get a hit, but my step is much smaller. Okay? And then again, now there's feedback coming from the formula itself. All right? And it says, well, okay, I'm getting close. I'm going to take another sample, but I'm going to take it in a smaller step. So now I have an even smaller step. There's a new sample. There's no hit. All right. Let's take this right here and put this over here. That's our fractal surface. Same thing. All right. Here's our ray. All right. And we're going to take this guy right here, and we're going to put it right here. I'm just kind of blowing this out, zooming it out. And it says, well, okay, I'm really close to the surface. Let's have it. I'm really close to the surface. Let's have the step size. Have it. Cut it in half. I'm really close. Let's have it again. I'm really close. And bingo, I got a hit. All right. All right, let's clear the board. And let's look at that again. So here's my camera. All right. I'm going to shoot out a ray. It's just a mathematical construct. All right, there is my Mandelbulb. All right, and I'm All right, it's going to say, I think it's safe to do a step here, to do a sample. I think it's safe. I think it's safe. I think it's safe. Oh, I'm getting close. Going to cut it in half. 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 Bingo, I got a hit. That is the ray marching process right there. All right. Understanding just this right here puts you in really good condition to be able to understand what's going on in order to render each of these pixels. All of this process right here, this whole process, all right, was just so that we could get one pixel on the screen. All right, just one pixel. That's the whole thing. Now, I know this is exciting. And now let me pull back in what we were talking about with this DE stop. All right, relating to our rendering process. Okay. So let's get back over to our screen and let's reconstruct our environment. All right, there's our fractal. We're going to shoot out a ray. Actually, I shouldn't have put an arrow there. We're gonna shoot out a ray like that. All right. Now, all right. So now, okay, yeah, okay. We're gonna do steps along the way here. Okay. So now what I want to do is I'm going to take this. Matter of fact, you know what I'm going to do? I'm going to make this a little bit. All right, there's our fractal surface. I'll tell you what, let's get rid of that camera. Let's have our ray coming in. Okay, you can imagine there's a camera over here. Okay. All right. Now, all right, so my step is coming in. The step is getting smaller. It's halving each time, that sort of thing. Okay, there we go. Okay, there we go. So right in here, this is a key point. Right at that, just when the steps are coming in and they're getting really close to the fractal surface, some real magic happens. All right, so this DE stop that I was talking about, let's get that up here. DE stop. Okay. What that is, it's a value that is assigned to the stepping process that is actually a threshold. It's basically saying that how accurate the ray stepping needs to be right at the point where it's about to hit the fractal surface. It's a threshold. All right, as I demonstrated earlier, a threshold of 0.1, all right, versus a threshold of, what did I do, 10? 10 is a very large threshold, and 0.1 is a very small threshold. And that simply means that as I get closer to the surface, a 0.1 DE stop value is going to try to be absolutely accurate. It's going to be so precise that it's going to render this point at great detail. And over here with the DE stop of 10, it's going to be much more relaxed about defining the surface at that point. All right, so all right, let's clean up a little bit here. All right, let's get our fractal back out there. Let's get our ray here. Okay. Now, with the DE stop of 10, the the stepping, when it gets really close to the fractal surface, the stepping will tend to be very ill-defined, okay? In other words, the last step will be somewhere in this range. So the point is that the step that's really, really close to the surface may or may not hit the surface. All right? It may overshoot the surface, or it may undershoot the surface. This is called undersampling, and this is called, you got it, oversampling. The final step of the ray went too far and went into the fractal. What you're probably going to see there is a black pixel. That's not black. Pretend that that's black. You're going to see a black pixel. If it undershoots, you get what I showed you before. You get very fuzzy, lack of detail. All right? All right. I hope this is making some sense. All right. So now, all right, get my thing back in there. Oh, I don't need this. Okay. Let's get my ray. Okay. Now, let's say that I set a 0.1. Now, you remember now I did my threshold. I did, you know, out. I'll tell you what. Let's do my previous threshold was like that. Now, this new threshold is like this. It's so tight, which means that when that final step gets to the fractal surface in this one particular ray, we're only working on one pixel at a time, the threshold, the DE stop, is going to be so precise that I'm going to tend to get ultra details. Over detailed. I'm really going to get, I'm looking at the fractal surface too closely. Let's go back to our fractal and let's revisualize this. So a DE of 10, DE stop of 10, gave me that very soft, all right. So basically that step stopped short. It stopped very short of the fractal surface. It stopped so short that I couldn't get much detail, and everything is soft. It's not focused. Focus is not the proper term, but to help you kind of visualize this, it's just blurred. The detail is lost. All right. Now let's do that 0.1 and render that out. All right, and now you can see here. Now let's go back to our drawing. Okay, let's get fractal here, and let's get our ray here. All right, and it got so close that it's actually it's amplifying every small little detail and artifact. Now let's see if we can get our heads around this. All right, maybe I could do it with some drawing. All right, so my DE stop. It is an absolutely critical control in terms of the rendering system. The DE stop is the beginning of where you're going to get good quality renders. It certainly is not the last, because there are some other things here that are very important to the rendering process. But this DE stop is the beginning point. I don't know if it means that it's on the top It's the top one in the panel, but it's a critical control. So the DE stop. When the DE stop is very low, all right, 0.1 for instance, 0.5 low, okay, it's just low. When it's very low, what happens is that the detail, your detail, let's get back over here and label this. We'll call that the value, okay? When the DE stop is low, the detail tends to be rendered. More detail tends to be rendered, all right? And also, let's see here, okay. Well, there, let's go blue for render. The render time, tends to be higher because the rendering system is working harder to get your details, so the render time is higher. Okay? When the DE stop is higher, I had used 10 as an example. It could be 8, could be 6, whatever. All right, the detail tends to be lower, and the render time tends to be lower as well. So I think you can see where I'm going. Somewhere in the middle here, we're going to have a good balance between the detail and the render time. So your DE stop, what you want to do with the DE stop is find a good point at which the render quality is good, but the render time is also good. So you want to be somewhere in this sweet spot here. All right. The trick is getting there. All right. Most people will simply experiment with the DE stop until they get something that looks good. And we can do that too. I come back over here. I'm going to set it to, and I had done this before. Let's set it to 2. Let's calculate that. All right. Take a closer look. You know, it could be better. That will not, this particular image would not, it would not print well. It wouldn't print well, and it wouldn't look good in an animation. So, okay, so I say, well, all right, then how about if I try 1.5 and render that out? All right, now, okay, so we're starting to pick up some detail now. You see these little dots right here? All right, that's these over here. These little holes here in this object. All right, it's better, but all right, so now I say, well, how about if I do 1.2? Okay, calculate that. I'll take a closer look. Okay, now I'm starting to get some detail back. The holes aren't as messed up as they used to be. Okay, so then I said, well, how about 0.8? All right, so, okay. So we'll do 0.8. Okay, now we're starting to pick up some detail. It's starting to look a little bit better. Okay, all right. So what happens here is with the DE stop, you're trying to find a point where the render time is, the quality is balanced with the render time. Because keep in mind, with a 1920 by 1080, you've got 2 million of these rays that need to be shot out. All right, you got 2 million of them. So you want to kind of pay attention to, well, how much time do I want to allow the system to render a full 2D graphic, or if you do 4K, you know, now you're getting into whatever it is, 8 million or something like that pixels. All right. So what you're trying to do is to find a good balance in terms of the DE stop. You're trying to find a good balance between quality and render time. All right. Now, you could certainly do this by playing around with the DE stop. Adjust it up, go down, tweak it around, see what you can do. And that's probably how most people do it. But there's some concepts in here that are important to keep in mind. All right. For instance, you ask yourself, well, what kind of a Mandelbulb surface do I have here? All right. Now I'm gonna turn your thinking 180 degrees. All right, because before I just took the DE stop and I just messed around with it and I experimented with it. Okay, fair enough. You know, that's certainly a way to do it. Another way to do it is to, now that you understand what the DE stop is, and just a refresher, just as a refresher, this is important. All right, a high DE stop will give you a threshold, a larger threshold of where the final step in the whole process stops relative to the fractal surface. All right, a small DE stop will have a smaller threshold in terms of the final step to determine or to render out that point of the fractal surface. So, if I have a fractal surface which is very smooth, all right, and let's make another fractal surface that's very rough. Now, okay, so if I shoot out a ray, and then I can probably do a fairly small DE stop or threshold, all right, because that fractal surface is probably going to be much easier to define than this bad boy over here. All right, in that case, with a very rough, very noisy surface, I probably would want to have a DE threshold that's fairly tight. Now, all right, let's go over here and let's take a look at what we have in terms of a Mandelbulb. This surface here, let me pull the parameters over. This surface tends to be very detail oriented. I'm probably going to need a DE stop that it's a threshold now. Think of the DE stop as a threshold. Just retranslate it in your own mind. It's a threshold. I'm probably going to need a DE stop threshold which is of a lower value for a render like this. All right? And the reason for that is because I have a lot of very high detail surfaces within that frame. So I'm going to need a DE stop that is more precise. All right. Let's see if I can. Okay, here we go. Oh, okay. Let's see. Here we go. Here we go. So this surface right here would not require as high of a as low of a detail, as low of a DE stop as the other one did. Why don't we try it? Let's push this over to main, and I'm going to render it. All right. Now this is the DE stop of 0.8. I could probably get away with a DE stop of, let's say 2. And the surface here still looks pretty good. All right, that I had a 0.8 before. Let's do it at 0.1. I'm just demonstrating that these smooth surfaces normally don't require a very low DE stop, because I don't need to be as precise on the surface as I needed to be over here. Let's see. Okay, here we go. So what I'm going to do is I'm going to push this navigator image over to the main, and I'm going to leave my DE stop at 1 just to demonstrate. So let's push that back over to main and let's calculate. Now you'll notice here that I am losing quite a bit of detail. If we just look at the navigator renders at low detail. The navigator actually has more detail than my main screen. All right. So, which illustrates that a DE stop that is 1 was not really appropriate for this particular detail level. But a DE stop of 1 was okay for that other image that had a lot of smooth surface. All right. So this is illustrating that this DE stop here is actually very important for purposes of detail. So let's go back. I got a nice smooth surface, and here I've got a rough surface. Well, let's make that a little rougher. A rough surface. I'm having a trouble here getting a rough surface. All right, there's my ray. So my DE stop here, can be a bit more relaxed, a higher value. All right. A higher value, which means a larger threshold. I can be a little bit more relaxed here in that very smooth. Over here in the rough or the high detail fractal, my DE stop is going to want to be lower, so a lower value, okay, because I have more detail that I have to contend with. All right. Understanding what the DE stop is and does is key for you to be able to get a good render given the complexity of the Mandelbulb objects in your scene. And it really comes down to that. The DE stop is a critical, it's a critical control that most people don't understand, but now you have a better handle on it. Don't think of the DE stop as the only control that's relevant here to this rendering. It is one of the important ones, but these others are going to be, I'm pointing to something you can't see. These others here are going to be very important to your understanding how to get a good Mandelbulb render out of your system. So let's recap a bit here. All right. I personally, I think that this is, I think it's fascinating that the Mandelbulb application developers actually brought these controls forward for the creator, the user of the Mandelbulb application, to actually be able to use. And if you know how to use these controls skillfully, then you're probably in the 10%, maybe the 1% of Mandelbulb users who are skilled in understanding what these controls do and how and when to use them. If you understand these controls, you're in a position to get the best possible quality, all right, as well as a balance in rendering. I mean, okay, I mean, take 20 minutes to render a pixel. Okay. But normally we don't do that. We want to get the render time down, but yet the quality up. So we're looking for a balance between the the quality that's rendered out and the render time. Excuse me. All right. So okay. So there's more going on here behind the scenes than I've told you so far. But this is a really good place to start, to understand the DE stop, the threshold. All right, so let's go back over here to my black screen. Now, just so that you understand, so that you're not throttled to what I've described so far. In other words, the DE stop gives you good quality. It actually does a lot more than that. All right. Now, certainly, I've already demonstrated to you that the DE stop value will get you sharp images. It gets you a good detail rendering if it's adjusted correctly. I mean, I showed you a DE stop of 10, got everything very soft. Well, yeah, but you can do better than that. But a detail of 0.1, a DE stop of 0.1 got you oversampled, it got you garbage. So somewhere in there. So sharpness is one of the key results of a good DE stop setting. All right. The DE stop also, all right, will give you or reduce or produce artifacts. Let me see if I can demonstrate that for you. Let's see. Okay. Let's go back here. Let's go back over to our navigator. Let's see if we can do something here. You see, this solid flat orange. It's indicating that my camera is actually inside that portion of the fractal. All right, so I don't want to do that. So what I'm doing is I'm just manipulating the scale because I want to get you something here that is reasonably good to look at. Okay, so let's walk in on this. Okay, there we go. All right, this might actually be a good place to start here. Let's see. I'm going to walk in even harder than that. That's pretty significant. Let's push that back over to main, render it out. I'm rendering with a DE stop of 1 because that's what I happen to have. All right. Now, let's go in even harder. I'm going in real hard here. Real hard. That might actually work for us. This amazing box formula is absolutely amazing. And when you combine these two amazing boxes like this, and then throw an A-box vary into it, you can get some really cool stuff. All right, let's push this back over to main. All right. Okay. So let's put this back down to 0.5. How about 0.5? All right. Put our magnifier on. Let's see what we get here. All right. Okay. All right. Let's go in even harder. Wow. My goodness. You know, it is this particular Mandelbulb formula combination is just like, it doesn't know where to stop. It just goes on and on and on. Let's put 0.1 in, oh, let's get it back over. All right, let's put a D stop of 0.1, just to go to extremes, that's all, just to go to extremes. Take a closer look at that. All right, I'm getting a lot of artifacts. All right, there's a lot of noise and junk in here. See where my mouse pointer is? You know, that's all junk. Artifacts. All right. So the DE stop is going to it's gonna have an influence on the sharpness. It's going to produce or reduce artifacts. Okay. But it also has a significant role in lighting. All right, and the reason for that is that if your pixel on that particular ray is well defined, then the lighting is going to be more accurate. All right, the artifacts, if the DE stop is way off, you're going to get artifacts, and those pixels are going to begin to show junk. All right, and of course sharpness. If the DE stop is right for that particular graphic environment, then your pixel is going to look good. But lighting is it's very important to understand that a good render, which the DE stop has a vital role in, is important for lighting. All right. Another aspect of this is called ambient occlusion. All right, and that is ambient occlusion is the light that is in the scene. All right, it's floating around, it's in the atmosphere, and it's hitting the Mandelbulb surface. Diffuse lighting is lighting that is being reflected off of the surface. I'm being very, very simplistic here. But ambient occlusion actually has a very much to do with the DE stop. All right, and also shadowing. All right, so the lighting and the ambient occlusion and shadowing has everything to do with what are called normals. So let's take our Mandelbulb surface here. All right, and let's take our ray. So our ray comes in like this, and we get a hit. Right? There's a calculation that goes on that says, what is my normals? So the normal would be 90-degree angle from the surface, the hit point of the Mandelbulb. And so if I have a proper normal, my calculation is going to be 90 degrees off of that particular point of the Mandelbulb surface. All right, as it turns out, lighting, ambient occlusion, and shadowing are derived utilizing the normal. If the normal, let's take another ray here, okay, all right. Now we're looking for 90 degrees, but let's just say that our normal here, for whatever reason, is off. It's not 90 degrees. Well, that's going to have an impact on your lighting, your ambient occlusion, your shadowing, and other things too, but that's enough for now. All right. The key point here is that your normals, the normal calculation, how close the calculation is to 90 degrees off of the surface, the point, the hit point, surface of your Mandelbulb, that normal accuracy will have a lot to do with the quality of your lighting, ambient occlusion, and shadowing. All right. Now, All right, with that understood, if I have my Mandelbulb surface, I got a ray coming in. If the remember the DE stop now is the threshold. Let's say that the threshold is very large. All right, and so let's say that for whatever reason, the Mandelbulb, the last step does not accurately determine the surface of the Mandelbulb surface. You're not going to get a good normal. You're going to get something else, because it doesn't really know where the surface is. It stopped looking here, but your surface is here. Okay, so it doesn't really know where the surface is. So the normal calculation is thrown off. If the ray oversamples, comes out here and shoots here, maybe I'm in the middle of the fractal, or maybe I've just passed right through a very thin-skinned Mandelbulb. Well, again, your normal's not going to be calculated correctly. So the DE stop is very important for lighting. Okay? All right. Now, all right, we're coming up on an hour. Let's keep this thing reasonably, because we're going to get our brains fried if we're not careful here, and we can pick this up in a subsequent live stream. But let me just summarize what we talked about here today. Let's get a fractal surface in there. Let's get a camera in here. Right. I'm going to shoot out a ray. Now, by the way, if I was to shoot out a ray that missed everything, all right, I got my steps, missed, it just says, okay, there's nothing out there. That's a miss, and there's no object there, and so you're going to get a pixel that doesn't really have any information in it relevant to the surface. But where we do hit, that's key. So in summary, what it does, what DE, all right, what DE ray marching does is for every pixel, it shoots out a ray, which is a mathematical construct. All right, and along that ray, it says, what is a safe distance for a sample? All right, whatever that distance might be. And it says, okay, no hit. All right, fine, no hit. Okay. So let's do it again. Let's shoot out another one at approximately the same distance. All right, and it says anything there, nothing there. This right here is called a step. All right, and the step size, the length, the size, is based upon a distance estimate. It's a best guess. All right, and so it says, well, okay, well, let's do it again. All right, let's sample. Did I get a hit? No hit. Okay, and you see where this is going. All right, now from some data that comes off of the formula itself, it's being fed into this calculation so that the calculation has some idea that it's coming up on and is about to hit a fractal surface. So it says, geez, I'm getting close, so let's make the step smaller. All right, and let's make the step even smaller, like that. So what I'm doing is, picture yourself walking towards a wall, and you got a little radar cap on, all right, but it's all black, you can't see anything. And as you get closer and closer to the wall, you move less, you don't step as much. You go to tiny baby steps so that you don't hit the wall too hard. In the case of the rendering, What we want to do, what we don't want to do, is that we don't want to overshoot the surface, and we also don't want to undershoot the surface, because as I showed you, this is going to give you a very soft look, and this one right here is going to give you artifacts, or you're buried inside the fractal, whatever the case may be. So what the whole point of this process is to get as close to the fractal surface as possible, and then call that a hit and run off and make a pixel. All right? So the DE stop is one of your first controls that will determine just how precise the ray stepping is going to be. All right, a higher DE stop is going to have a larger threshold. A lower DE stop is going to have a smaller threshold. And knowing when to set your DE stop accordingly is one of the skills of being able to work with the Mandelbulb application so that you get a really good quality render. And you get a render in decent time, rather than having it just sit there and spend 20 minutes trying to make a pixel. That wouldn't work for anybody. Okay? All right, so that's the end of this live stream. And I think that this was probably, arguably, this is probably the most important tutorial that I have ever done on the Mandelbulb application. I think there's like 408 videos up on my channel, up on the Learn Mandelbulb3D channel, YouTube channel. And in all of those, I didn't bother to really explore with my students the whole rendering process. I knew about it, but I just felt that it was just too deep for people to understand this whole calculation detail. And I touched upon it, from time to time. The formulas tutorial series, I did get into this. But I decided that I wanted to really get into it and show people how to get the best possible render quality out of your work. And understanding these controls is probably 80% of the effort to get a good quality render. Yeah, and certainly within a reasonable render time. So we're going to pick this up again. I'm going to do another live stream. Let's see, what is it? The 24th? Yeah. May 24th, I'll schedule another live stream at this same time, Sunday, 4 o'clock Eastern time. Yeah. We're going to continue the discussion. And I'm going to move on to other controls like this Raystep Multiplier. We'll talk about that step width limiter. Those are very important, probably as important as the DE stop in terms of getting your render quality. All right. Now I put together a Discord server that is specifically for the discussion of the Mandelbulb3D application. We're not talking about Mandelbulber. We're talking about only about the Mandelbulb3D application. That's a place where anybody with an invite can go to discuss the Mandelbulb. It's not really intended for people to put their pictures up and say, hey, what do you think? It's more intended to continue this education and address specific needs and what people are looking for and confusing areas. So I wanted to use the Discord server to kind of extend the whole teaching process. All right, so there's that. So I'm going to leave an invite link in the description of this live stream. Click on that, and that'll take you right to the Discord server, which I've titled Learn Mandelbulb3D. All right, so there's that. I also encourage you to subscribe to the YouTube Learn Mandelbulb3D channel so that you get good notifications as I schedule out more live streams. I don't really see myself in preparing pre-recorded tutorials. I don't see myself doing that in the future. I see myself more creating these live streams because I want people to be able to jump up, chat, take a look at things, and go over to the Discord server and put your questions in there. I'll monitor it, manage it, that sort of thing. And all right, so that's it. So that's enough for this live stream. I'm going to schedule another one for May 24th, same time, Sunday around at 4 o'clock. And we're going to continue our discussion of these rendering controls. Okay? So, thanks for joining me in this live stream. I'll see you in the next one. You take care. Bye-bye.